So I've already mentioned this in 2-1, but here we have the next couple of concepts. We have something called the axis of symmetry. All right, and this axis of symmetry is merely that every parabola has a line or imaginary line that divides the parabola into a mirror image that passes through the vertex. Okay, so if it is passing through the vertex, it is typically going to be a vertical line. And so if we go over to our picture here and we look at this, we see we have a vertex at this location. And this is the order pair 3, 1. All right. From here, if I wanted to draw my imaginary line, it would go through the 3. That is right here. Okay, and so we could say that the equation of this line is actually x equals 3. And notice how this 3 and this 3 are equivalent. And in fact, this is going to happen every single time. So below our definition, it says it's written as x equals h. And it has the letter h because your axis of symmetry will always be the first number from your vertex, or the h value. So this is what we're using, and just remember vertex is HK. So in example 1, and again, this is something we've already done, but now we're just going to graph it. Example 1a on the left-hand side is negative 2 times the quantity of x plus 3 squared plus 4. If we were to follow our directions from the origin, the positive 3 on the inside means we need to go to the left. And then the positive 4 on the end is going to say we need to go up. So if I go to the left 3, and up 4, then I should have a point around here. And from here, I just need to note that my a value is telling me to reflect. So instead of my parabola moving or opening upwards, it's not going to be opening downwards. And so I should have a, from here I can do rise over run with that 2 for the quadratic parabola shape. And so I can have a point here and a point there. So all I need to do now is connect the points. I'm going to put some arrowheads. There we go. So I can draw the picture first and then answer the questions, which is graph it and then label the vertex and the axis of symmetry. Our vertex, again, is just our highest or our lowest point, and the axis of symmetry is going to go through the vertex. So I can actually draw my line here, and then I can write that the vertex is negative 3, 4, and our axis of symmetry is x equals negative 3. To the right of that, though, it says x minus 7 squared minus 1. So our vertex, if I were to graph this, it's going to be to the left 7, down 1, which is right here. And my next 2 points are going to be there and there. And I only know that because I guess you could say my slope is 1. So 1 over 1, you know. And now that we have this, we can connect our dots to our arrowheads and answer the question. Our vertex, as we said before, is 7, negative 1. And our axis of symmetry is going to be 7. So a couple examples that we can do, a couple more examples I should say. On the left-hand side it says negative 4 times the quantity of x minus 2 squared plus 2. We can easily write our vertex from here. It should be 2, positive 2. And if I were to put my point, it would be right there. And then from here, I can see that because it has a reflection, I know it's going to be facing downward. So whenever I follow my A to my other 2 points, I'm going to be moving down and to the right by 1, or right and left. So I should have a point here, and then another point there. I can connect my dots, and there we have our graph. The next thing I can do is do my axis of symmetry. So I'll draw my line, and I'll say it is going to be x equals 2. For the next one, what I want you guys to do is change it to, I guess you really don't have to. Remember that 0.75 just means it's 3/4 x squared minus 5. You don't have to change it, but sometimes it's easier to see it in different ways. Some people get very overwhelmed by decimals, so that's why I just wanted to show that to you really quickly. But we are going to follow our directions. We do not have any horizontal movement. We only have vertical movement. So I'm going to go down from the origin 5 times to get a point here. And then I'm actually going to use my calculator to figure out where's another point. If I plug in a 1 or a -1, it's going to give me a decimal, which is a little hard to work with. So I can try plugging in a 2, and that actually gives me the points 2, -2, and -2, -2. So here are my 2 points. And I can connect the dots on my little arrowheads, and then I can answer the questions. I can say that this point here is 0, -5. My axis of symmetry is going to be x equals 0. All right, still following that format. The little bit of notes below is just pointing out that if a is greater than 0, if it is positive, we are going to have a maximum. But if it is negative, well, then we're going to have a minimum. It's going to be opening downwards, so that's where that maximum comes from. So the next section is a really good section to know. We are introduced to a new formula called the standard form, and the standard form is a very helpful form. It can help us get into vertex form. It can help us in our intercept form. There's a lot of different things that we can do with our standard form. But even before we change from standard to vertex to intercept form, we can pull some information from this to give us an idea of what our graph looks like. So the first thing, the first property to know is that when it's greater than 0, when A is positive, well, that means it's going to be opening upwards. And if it's opening upwards, that means we have a minimum. So if it is less than 0, that's when it opens downwards, and that is when we have a maximum, okay? Same thing as what we said before, but we're just showing you that the A that tells us the same thing in vertex form can now be applied in our standard form. So they're across both formulas, they're telling us the same thing. The next property is, what type of number is A? Again, A is telling us the same thing. If it is greater than 1, that is a whole number. It is stretching. If it is a fraction, if it's between 0 and 1, well, that's going to be shrinking. All right, so then the next thing is C. And if you look at your picture on the right, C is right there. And so we can say that C is our y-intercept, which it used to be our y-intercept was represented by b, right? But no longer, because y equals mx plus b is a linear equation. But this is no longer linear, this is quadratic. And so now b has a different responsibility, and we are going to represent the y-intercept as c. So we make sure when you're writing your y-intercept, it's in the format of 0, comma, the number, which is your y-intercept. The last two things I want to point out for this particular thing are probably the most useful, and that is your axis of symmetry formula. So obviously, if you're in vertex form, you can easily identify what is your axis of symmetry. But unfortunately, in standard form, I don't have an H or a K. I have A again, so that's the same. But then the other two variables are B and C. Those are not very useful. So because they're not very useful, I can sort of ignore them, and I can say, I can't see my vertex with B and C. So what they did was they created a formula to help you identify your axis of symmetry, which helps you identify your vertex. So the axis of symmetry is going to be x equals negative b over 2a. And this is the most important piece from your standard form. After you find this x value, remember, it's the same x value as your vertex. So if you have an x value, you can actually plug it back into your equation to get your y value. So if I want to find my vertex, I'm going to take my axis of symmetry and plug it in. And so how we show that in math is we say the vertex is going to equal negative b over 2a, that's the axis of symmetry, or your x value, comma, and then you're going to plug it into the function. So I'm going to say f of negative b over 2a. Let me add that negative, not with a highlighter. So example 2 is using the properties that we sort of talked about before with our standard form and applying them to actual equations. So it says find the vertex on the axis of symmetry and determine if the vertex is a minimum or maximum. Well, before we even start, we can actually determine if it's minimum or maximum. We can say, all right, it's going to be the minimum if A is greater than 0, because if it's opening upwards, that means I have a bottom. And if it's opening downwards, therefore it is negative, or A is less than 0, well, that means I have a top or a maximum. So I can look at each one of these and quickly determine, is it a minimum or a maximum? So in part A, it is a positive 1, and so because it's positive, that means I have a minimum. All right, the next one, negative 2. It is negative, so therefore I have a maximum. All right, part C is negative again, therefore I have a maximum. So again, I'm just going through and I'm only looking at A. I don't really need to look at anything else to determine easily if I am having a maximum or a minimum. So let's do the last 3. It should be pretty quick. Positive 3, that is a minimum. Negative 1 is a maximum, and positive 6 is a minimum. All right. Now that we've gone through and identified minimum and maximum, we can now find our vertex and therefore find our axis of symmetry. So we are going to use our equation that we had before. Now remember, your equation is ax squared plus bx plus c. And remember, all of these numbers correspond with a location. So c corresponds with this location, B corresponds with that location, and A corresponds with this location. If you don't see a number, but you see the variable, then it's an understood 1. And if you don't see the number or variable at all, then of course that's going to be 0. So in this case, we have everything. The only number we don't exactly see is the number in front of x squared, which is going to be 1. So I'm going to take this and I'm going to plug it into my formula. I'm going to put it off to the side so that we can see it. But it should be negative b over 2a. Again, you get your numbers or the letters from the location. All right, so this is going to say, here is my vertex and symmetry. X is going to equal negative 2. All right, remember, the formula already has the negative sign in it, as you can tell. So that's why I am making my negative, or my 2, negative, because the formula tells me to. So negative 2 over 2 times 1. So that's going to equal negative 2 over 2, which equals negative 1. Well, now that I have this x value, I'm going to plug it in and get my y value. So I'm taking my equation and I'm filling in all of my x values with the negative 1, with that number I just found. Once I plug it in, I just need to do some math. Negative 1 squared is 1, 2 times negative 1 is negative 2. Carry down the minus 1. If you add all that together, you should get a negative 2. And so our vertex is going to be negative 1, negative 2. And after we find our vertex, it's very easy to tell what our axis of symmetry is, okay? And so that's the step. Same idea with the next one. We have our A value, our B value, and our C value. We don't really need the C value, but we're going to plug it into our negative B over 2A. You will definitely have to memorize this formula. So X is going to equal negative, and I'm going to use parentheses because not only is the formula negative, but now my number is also negative. So it's going to be negative 8 over 2 times negative 2. Well, 2 negatives make it positive, so that's going to be positive 8. And then the new denominator is going to say negative 4. 8 divided by negative 4 is negative 2. Once you find your x value, you need to plug it into all of your x values. Okay, so that's this point here and here. So you're going to rewrite everything. Y equals negative 2, plug it in, squared, minus 8, plug it in, plus 1. Then we do some math. Negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 times negative 2 is a positive 16, and then you carry that plus 1. Negative 8 plus 16 is 8. 8 plus 1 is 9. So I'm going to say that my vertex is negative 2, comma 9, and my axis of symmetry is negative 2. Last one, letter C. This one we're missing some stuff, but it's okay. If we are missing something, it's just an understood 0. So my A value is that negative 3, and my B value is missing. And if it's missing, the number that represents nothing is 0. So if I plug this into my formula, it's going to be x equals negative 0 over 2 times negative 3. If I keep going, it's just going to equal 0. Again, even though it's the number 0, it's still a number. We have to plug it into our equation. So I'm going to plug it into the only x position that I have. So it's going to say negative 3 times 0 squared plus 9. All right, well, obviously 0 squared is 0, and 0 times negative 3 is 0. So it ends up saying 0 plus 9, and 0 plus 9 is 9. So my ordered pair, or my vertex, is 0, 9, with an axis of symmetry at 0. So the intercept form is a useful thing to help you get an idea of what your particular function is going to look like and where. There's a lot of things happening, and it doesn't particularly matter which order you go in, but when you're in intercept form, obviously you can still figure out if you're going to have a minimum or a maximum. You can still figure out what your vertex and axis of symmetry is, but the nice thing about the intercept form is that it takes it a step further, and you can find your x-intercepts. Not your y-intercept, but your x-intercepts, and typically you'll have 2. Not always, but most of the time, I guess you could say, you are going to have 2. So first things first, let's start with the things we are used to. Before I get started, though, I do want to point out that this intercept form and the example below, I'm just pulling what that p value is and what that q value is. So p is going to be negative 3, and q is going to be 1. And for the vertex, they're going to want me to use this formula, p plus q over 2. And I got that from the picture to the right. Now that I have this formula, I am going to go ahead and plug in my p and q. That'll give me negative 3 plus 1 over 2. I'm going to figure this out, and it should end up being a negative 1. After you find your x value, it's just like our previous example where we plug it back in to get our y value. So I'm going to carry everything down, and for every x position, plug in a negative 1. So it should say negative 1 plus 3, and then negative 1 minus 1. When you are doing this, make sure you're following PEMDAS or PREMDAS, where you are working on the inside of your parentheses before you move outside. So the negative 2 is just carried down, and in the first parentheses, it would add up to 2, and in the second, it would be negative 2. If we multiply those 3 2's together, it will end up with a positive 8. So my vertex should be the ordered pair negative 1, 8. I'm just going to box that in. After that, I can easily find my axis of symmetry. It's the first number of my vertex, so it would be x equals negative 1. Box that in. Then I can easily tell if it's going to be a maximum or a minimum. I have this negative in front, therefore it is opening downwards, and I should have a top or a maximum. Box that in. So then the final piece is your intercepts. Your intercepts are very easy to find. All you're going to do is take both of your parenthetical statements and set them equal to 0, and then solve for x. So in the first one, it's going to say x plus 3 equals 0. If I subtract 3 on both sides, x will be isolated, and I'll have x equals negative 3. So that's one of my x-intercepts. Do the same thing for the other parenthetical statement. X minus 1 equals 0. Bring over that 1 by adding, and we'll end up with a positive 1. So my x-intercepts are going to be at negative 3 and negative 1. So what is that going to look like? Well, after I do this, I can easily get an idea of what my picture is going to look like. If I wanted to draw the picture, I would say, here is my coordinate plane, and we're not going to be super exact, but let's go ahead and do this. We have a point at -1, +8, +8. So actually, let me move this down a little bit. There we go. -1, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be way up here. That's going to be my vertex. My x-intercepts are going to be at -3, which is somewhere over here, and +1, which should be right there. And it's opening downward, as I've already mentioned. My axis of symmetry is at -1, and so my parabola is going to look something like this. And again, the whole purpose of this is not really to force you to graph, but to give you an idea that in the different forms that you have, you can easily get good points in order to graph if you need to. So let's get these last couple of examples out of the way. We're doing the same process as we did before. So in the first one on the left-hand side, part A, we have -1 times x plus 1 times x plus 5. All right, first things first, I'm going to find the easiest stuff. I have this negative symbol, which means I'm going to have a maximum or a top. Then after that, I'm going to go ahead and try to find my axis of symmetry, which leads to my vertex. I'm going to pull my p and q values, which is the opposite inside of there because of the formula. And so it would be -1 and -5. I'm going to plug that into the formula. X equals -1 plus -5 over 2, which should equal, after some math, a -3. So I can automatically say, well, my axis of symmetry is going to be x equals -3. Once I'm done with that, I can now plug that -3 back in to get my vertex. So that's going to be y equals -1 times, plug in that -3, plus 1, plug in the -3 again, plus 5. Do some math. You should end up with a -2 and a +2 multiplied together, and you should get a 4. So my vertex is going to be -3, +4. After this, I can do my x-intercepts. You can, again, do any of these in any order. It doesn't really matter. I'm just going with what's easiest. So I'm taking my parenthetical phrases, x plus 1 and equaling to 0, and doing the same thing for that x plus 5, equaling it to 0. Now I'm going to solve for x. Subtract 1 on both sides for this one. I get x equals -1. And then for the other one, I'm going to subtract 5 on both sides to get x equals -5. So my x-intercepts are going to be -1 and -5, and that's my answer. I love the little stair steps that I did. It's real cute. The one beneath it. So even if you have a fraction, it doesn't matter. The process is still the same. It's positive, so therefore we have a minimum. We have a -6, so it's a +6 for that p, and a -2, so a +2 for that q. Plug it into the formula. 6 plus 2 over 2 is 8 over 2, or 4. I know my axis of symmetry is going to be x equals 4. And then plug it back in to get your vertex. So I'm going to rewrite everything, but plug in the 4 for all of my x's. I'm going to do some math within my parentheses to get -2 and +2. And once I do that, I get a -1. Because really it's -2 times +2, which is -4, and -4 times 1/4 is -1. My vertex is 4, -1. The last thing I have to do is my x-intercepts. So I'm setting each one equal to 0, and then I'm going to solve for x. This requires me adding, and the other one requires me adding as well. So now my x-intercepts are going to be +6 and +2, and that's my answer. The last one I want to do is the one that looks fairly different. It says, instead of having 2 parentheses, I now have x minus 3 squared. So I'm going to go ahead and do this. And really, if you think about it, this is actually our vertex form. So I can sort of look at this and go, okay, my vertex should be at 3, 0. But we're going to do it like the intercept form, just to make sure that I'm doing this correctly. So I'm going to say, all right, I have a maximum because it is a negative in front. Therefore, I am facing downwards, which means I have a top. Then I'm going to rewrite this actually as x minus 3 times x minus 3, so it's easier to see my p and q. I see that they're both 3 over 2, so it's going to end up with 6 over 2 or 3, and I'm actually going to move this over here so it's not in the way. My axis of symmetry is going to be x equals 3. Time to plug it back in to get the rest of my vertex. Y is going to equal 2 times 3 minus 3 squared. Well, 3 minus 3 is just 0, and then 0 times anything is itself. So our vertex is going to be 3, 0. Now I'm going to go ahead and set that one statement. I don't need to do it 2 times because it's the exact same equation, but I'm going to set it equal to 0, solve for it, and I get 3. So I actually see that in this particular case, when I don't have 2 parentheses, I don't have 2 x-intercepts, which sort of makes sense because 1 parenthesis is 1 intercept. So if I only have 1, that means I only have 1 intercept. Anyway, that is this particular section. I hope it was helpful, and I will see you guys in class.